When our young nation resolved to survey our ocean and coasts, we set a course. As our population grew and commerce needed accurate weather predictions, we rose to the challenge. When our seafood supply faced an uncertain future and protecting marine life became essential, we answered the call. As our successes grew, so did we. And after centuries of learning, the sharpest minds in the earth sciences came together to form the National Oceanic and Atmospheric Administration. Our relationship with the planet is now more dynamic than ever. Shifting environmental systems and our understanding of them continue to shape the way we live, work, and explore. Today, we are stewards for a cleaner, healthier, and more sustainable ocean. Our innovation powers the blue economy. We protect life and property with every forecast and warning, driven by one of the largest streams of observation data on Earth. We are global leaders in environmental sciences and technologies. We soar higher, dive deeper, and venture farther to understand our changing planet. We are NOAA.
Hello, and greetings from Charleston, South Carolina, here on the eastern seaboard of the United States. My name is Kim Valentine, and in my current position as Acting Geospatial Information Officer for the National Oceanic and Atmospheric Administration, it is truly my pleasure to be with you all today. I have worked at NOAA for almost 2 decades and can say without a doubt, this is one of the coolest times to be working for America's data agency, and especially having the opportunity to speak with you today on behalf of NOAA's GIS community of users and data scientists. Hopefully the intro video provided a high-level overview of NOAA, where we came from, and where we are headed. I also hope that you saw all of the examples of geospatial technologies in use at NOAA, including satellites, aircraft, survey ships, and buoys. Today I will provide a brief overview of NOAA's core geospatial data assets and how we use GIS to support these within the NOAA mission. I will then turn it over to 2 of my colleagues who will demonstrate how GIS enables our NOAA scientists and researchers to meet our mission. And then we will close with a brief look forward at the NOAA science and technology priorities and how we see GIS fitting into the picture. NOAA at its core is a science and data organization. From a GIS perspective, it's a fascinating organization to work for. We collect data from the surface of the sun to the depths of the ocean and everywhere in between. We deal with a huge diversity of data types, data formats, and user communities. We try to stay on the cutting edge of technology adoption where we can, always with an eye on supporting the NOAA mission. But GIS is the integrating technology that stitches together this diverse set of data, services, and user communities into products that answer questions and address society's critical issues. In order to carry out our mission, NOAA is responsible for a vast array of observing platforms. These run the gamut from satellites to aircraft to buoys and tide gauges. NOAA's first operational satellite in deep space, called Discover, orbits 1 million miles from Earth in order to provide early warnings of potential harmful space weather. We are also beginning to deploy more and more unmanned or uncrewed systems. While these platforms are essential in maintaining world-class science and forecast products, the ever-increasing data volumes are challenging the organization to think differently about how we store, manage, and make accessible this vast resource of data and information. Within the US, we have the concept called the National Spatial Data Infrastructure. Think of it as the national map of the US. NOAA is charged with developing and maintaining many of the fundamental data sets driving our geospatial programs. Examples of this on the slide show geodetic control, nautical charts, weather and climate, imagery and satellites, and fisheries and ecosystems. For all these data types, proper data management is key, as is making them as discoverable and usable as possible. NOAA's mission is to understand and predict changes in climate, weather, oceans, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. Our mission is focused on science, service, and stewardship, and GIS is essential in our ability to meet this mission, now and into the future. I will now highlight a few examples of how we see this in action in NOAA. For the vast majority of Americans, the map they interact with more than any other is a weather map. Weather is, by definition, a location-based activity. Unfortunately, the weather forecast community was somewhat isolated in their tools and systems until fairly recently. Over the past 10 years, there has been a transformation within the National Weather Service, recognizing the value of making all of their various observations, models, and forecasts available as standards-based, compliant geospatial services. This has led to an explosion of the use of weather data in common operating pictures at emergency management agencies, on smartphone apps, and for use by the general public. A new satellite designed to capture detailed measurements of sea surface height and other ocean features is scheduled to launch in November 2020. The Sentinel-6 satellite will help provide enhanced hurricane intensity forecasts and improved information of Earth's climate. While our weather forecasts help communities prepare for severe weather, we also provide GIS support services post-events. When a tropical storm or hurricane hits the U.S. mainland, it's not unusual for shipping channels to be impacted. This can not only impact the community's ability to obtain critical response supplies, but cause delays in restarting normal business operations. NOAA works in partnership with other federal and state agencies to deploy navigation response teams to identify obstructions in channels using side-scan sonar and other technologies. This data is mapped and shared with others to prioritize the opening of shipping channels. NOAA also uses our fleet of aircraft to provide emergency response aerial imagery surveys after events like hurricanes, tornadoes, and earthquakes. This imagery is processed quickly and posted to a cloud-hosted service to allow citizens to quickly and easily assess the damage in their area. For homeowners that are forced to evacuate from a storm, for example, being able to see an aerial image and know their roof is still on their house brings a huge peace of mind. It is not just about providing data. You also need to do it in ways that the recipients can interpret it and use it in a meaningful way. Here are two examples. On the left is an image of a new NOAA storm surge product seen here in ArcGIS Online. NOAA's old storm surge products referenced a tidal datum, which might read something like, a Category 3 storm will produce a surge of 5 feet above mean low water. What this meant to the average citizen was really not much. So working with social scientists and user groups, we now have a new color-coded product that instead references surge to water above ground. So a forecast would now say a Category 3 storm will have water 4 feet above the ground. On the right is an interactive decision support tool that allows local communities to explore different sea level rise scenarios for their community. A user can simply select from 1 to 10 feet of water in a particular area of interest and can see what that will look like based on a very high resolution coastal DEM based on LiDAR data. Nautical charts are produced by NOAA's Office of Coast Survey, and they are the nation's nautical chart maker. We are responsible for upgrading charts, surveying the seafloor, responding to maritime emergencies, and searching for underwater obstructions that pose a danger to overall navigation. Managing the U.S. offshore fisheries is another NOAA responsibility. We are the leading stewards of the ocean for long-term sustainability by protecting vulnerable marine species while also supporting recreational and commercial fisheries and aquaculture. GIS is used to monitor fishing vessel traffic as well as catch data. This is coupled with data on the health of the fisheries to determine when to open a particular area and how much fish catch it can support. There is also a fisheries law enforcement component within NOAA, making sure that vessels are operating only in approved areas and not in marine protected areas, for example. And the last example is focused on NOAA's role in protecting our special coastal and marine environments, whether they be coral reefs, coastal mangroves, or deepwater kelp forests. Maintaining a healthy and diverse coastal ecosystem is essential. We use GIS in a number of ways within this community. One of the more innovative is in something we call participatory mapping techniques to gather information on ocean uses from community members that have no idea how to operate a GIS. This approach allows for attendees to use simple approaches like pen and ink or computer entry to identify areas of a given ocean region where they perform some type of ocean use, be it fishing, boating, snorkeling, or tourism. These data are then entered into a GIS and then used to define ocean uses. And now I'm going to turn it over to my colleague Randy Warren and then Mark Finkbeiner, who will demonstrate how GIS enables our NOAA scientists and researchers to meet our mission.
Thank you, Kim. My name is Randy Warren, and I'm a data manager with NOAA's National Ocean Service. What I'd like to do today is take just a few moments to demonstrate a specific GIS application that we use in NOAA to help meet our mission, and that application being the NOAA Geo Platform. So the NOAA Geo Platform is Esri's ArcGIS online product, which in NOAA we've been using since 2013 for GIS analysis, data dissemination, partner collaboration, and visualization, really being able to visualize our geospatial data. So what I'd like to do next is walk through just a few slides to help demonstrate some examples. So like I mentioned previously, we launched the NOAA Geo Platform in 2013, and at that time we had no idea how popular this would become for us and how effective it would be in sharing our geospatial content. So very quickly, why do we call it the Geo Platform? Well, in collaboration with several other U.S. federal agencies, such as the Environmental Protection Agency, we too call our ArcGIS Online instance the Geo Platform. In digging into some of the benefits that ArcGIS Online provides, I mentioned earlier visualization. ArcGIS Online allows our GIS users to visualize their data through maps, story maps, applications, and dashboards. Another important benefit that we've seen is that it has put GIS tools into the hands of typically non-GIS professionals. It has allowed these GIS beginners to quickly add, display, and analyze data, and then create these custom applications to meet partner needs. So now I'd like to show a few specific examples of how NOAA is using ArcGIS Online. First up, we have a series of dashboards created by NOAA's National Weather Service called Situational Awareness for Emergency Response, or SAFER dashboards. What these dashboards do is provide real-time information with custom areas of interest to provide situational awareness for decision makers and provide emergency managers with information needed to prioritize their responses. First in the top left, we have the hazards dashboard, which shows real-time watches and warnings for tornadoes, severe storms, and flash floods. Moving over to the right, the flood prediction dashboard shows just that, potential river flood predictions for your particular geographic region. In the bottom left, we have the tropics dashboard, which provides a snapshot of historic, current, and future tropical weather. And next up is the wildfires dashboard, which I'd like to take a little closer look at. So this one, called the SAFER dashboard for wildfires, is showing us real-time information about wildfires that are currently happening in the western U.S. The red symbols designate active wildfires in real time, and the size of the symbol indicates the number of acres that are burning each day. So in addition to those active wildfire locations, we can also display fire perimeters, historical fire data such as previously burned areas, and we can also look at model data and other projected and forecast elements. So in taking a little closer look, we've zoomed into our area of interest and overlaid 24-hour rainfall estimates, which would help responders to prioritize their response areas. Okay, so now I'd like to focus on another ArcGIS Online product, Story Maps. So when we launched the NOAA Geo Platform in 2013, we had no idea how popular story maps would become and how effective they would be in communicating our GIS stories. Our GIS users to date have published over 1,000 story maps, and what these story maps do for us is they help our GIS users really to provide context and to tell a story and to convey a message with their GIS data. In this particular example, NOAA's Coral Reef Program tells a story about the 2014 to 17 global coral bleaching event by using images, text, video, and geospatial data and maps. And as you can see, one of the areas of interest is the Great Barrier Reef. Okay, so far we've looked at applications for situational awareness and story maps as a communications tool. Now I'd like to take a look at the underlying data that helps to drive these products. So NOAA is currently using ArcGIS Online as another platform for disseminating our authoritative NOAA data, especially Esri map services. And to take it a step further, NOAA has partnered with Esri on the Living Atlas, which is Esri's curated catalog of geospatial content. Think of it as the best of ArcGIS Online content. NOAA has contributed dozens of authoritative data layers to Esri's Living Atlas. And by doing this, we know that ArcGIS Online users are more easily able to find those authoritative data and layers. Another benefit to NOAA is that the Living Atlas provides added visibility for our data. For example, the weather radar layer has been viewed over 22 million times over just the past few years. and that's just through ArcGIS Online alone. So hopefully this was a quick look into how NOAA is using Esri's ArcGIS Online to meet NOAA's mission. And now I'll turn it over to my colleague, Mark Finkbeiner, who will demonstrate a custom application that helps support NOAA's Blue Economy initiatives.
Thank you, Randy. My name is Mark Finkbeiner. I'm a physical scientist with NOAA's Office for Coastal Management, where I lead the Ocean Data and Tools team, and I specialize in marine planning, benthic mapping, and GIS. I appreciate the opportunity today to share the latest tool produced by the Marine Cadastre team, Ocean Reports, which is a way for us to reach beyond our traditional audience. And I should say at the outset that this tool is the result of a long-term partnership between NOAA and the Bureau of Ocean Energy Management. Before we look at the tool itself, I just want to give a quick overview of what it does and the audience we're hoping to serve through the tool. Ocean Reports provides summary information in the form of infographics, charts, and statistics that are extracted from over 100 complex data sets. The domain of the tool is the entire USA exclusive economic zone, including the territories, although it is weighted toward data in US federal waters. The target audience is broad and includes industry, government, and the scientific community, but is particularly focused on the non-GIS user. And we have designed the tool to provide results in moments so that you quickly get a report. In terms of how we see the tool being used, we envision it as a reconnaissance mechanism for assessing the suitability of an area of the ocean for a potential use. We want to be careful in our messaging that the results of the tool do not exempt you from a formal permitting process that may be necessary, but do give you an early indication of whether a site is favorable. The goal is this early assessment reduces the number of what are called permitting false starts. We've also found that with all the data in the tool already, it can serve a gap analysis role and directly supports some of our recent National Ocean Policy executive orders. And with that, let's take a look. The tool can be found on the Marine Cadastre website, where it's one of our featured tools. As you invoke the tool, you're presented with two options. You can view over 125 pre-calculated quick reports for areas such as federal waters adjacent to states, state waters, or special areas such as marine sanctuaries, national estuarine research reserves, or other areas. Or, and this is where the real power of the tool resides, you can draw your own polygon anywhere within the US EEZ and get an immediate report for that area. And I'll go ahead and do that. So we'll pick an area off Massachusetts here in the Northeast. And you can see it's generating the report. In terms of what you'll see when the report is completed, we have 6 major themes. General information, and these are located on the left side of the screen. Energy and minerals, natural resources and conservation, oceanographic and biophysical data, transportation and infrastructure, and economics and commerce. There is some descriptive text which introduces the statistics you're going to see, and at the bottom of the infographic right here is the rule set behind the statistical report. This is unique to each infographic and include features within the AOI or within the distance of your AOI. And this rule does vary depending on where you draw the box, whether you include only ocean space or include a portion of the landscape. There is a layer button as we come down here. Let's scroll down, where you can turn on the data and display it in the map. And this is useful for instances where the summary statistics really don't tell the story. The I button allows you to look at the legend in the map, and in this case we just have these points. And it's to note as a user, if you turn a layer on in your view, it will remain on in your map as you scroll through the various themes. And a new functionality we recently added is the ability to drag this box to a slightly different location if you weren't satisfied with the early results. So I'll just walk you through some of the different themes quickly to show you how we've presented the information. We've tried to be intuitive in these infographics so that it's information a casual user can relate to. So we've used tables, pull-down menus, and we often have links off-site to other websites and resources of interest. In the oceanographic realm, we're using compass roses and bar charts to illustrate climatologies for this type of data. We also have numerical counts that you can see. And finally, in the Economics and Commerce tab, we've used these bar charts to display the contribution of the ocean economy to the state or the county of interest. And so assuming that you're happy with your report and you've been able to browse through it, you'll now want to invoke this tool in the upper right corner where you can potentially share your results with a series of colleagues that are working together on a project. This link will return the result for the original drawn box. You also have the ability to access the metadata, and this can be very important in terms of describing your results to your additional audience. They'll want to know what is the vintage of that data and what was the source to make sure it's current. And finally, the final tool that you want to do before you leave is to print. And I won't hit this button because this actually does take some time. So here's where I'm going to switch back to a slide and just show you what your options are under the print functionality. So you can imagine with over 100 data sets in the tool, you may not want a full report of all those infographics. Here's where you have the option to select those of particular interest, and you can do that through these switches that are visible at the bottom of the page. And we've also taken the step of organizing the data by industry so that if you're interested particularly in sand and minerals or renewable energy, you can craft a report specific to those data sets that are relevant to that. We do know that there is some overlap in these industry categories, but it's a good starting point. And finally, as you hit the print button, the tool will generate a PDF that you can then share with your audience. And I'll close by saying that other groups have gone down this same road in terms of presenting information rather than just spatial data. And we've learned some lessons along the way, and we would look forward to consulting with those groups if it would be helpful. Thank you for your time.
Thank you, Mark. Now we will close out by looking forward. As you saw in the video, we are celebrating our 50th anniversary. This means we are reflecting on our agency's history, but also looking forward to our future. A couple of key areas where NOAA is focusing attention in this area include how NOAA is starting to wrap our heads around dealing with big data, including migration to commercial cloud vendors wherever possible. Also, NOAA's science and technology priority focus areas and how we adapt to these new technologies, especially considering the large amounts of new data and data streams coming in from these while still also meeting our mission. NOAA's wealth of world-class environmental data is now more accessible than ever before through partnerships we have with these commercial cloud providers, which allows the agency to better manage a rapidly increasing volume of data going forward. These commercial cloud platform providers will also generate untold opportunities for scientific and economic advances by exponentially expanding rapid and reliable, no-cost access to NOAA data for the public. Cloud-based storage and processing is in the future. Not only will this improved accessibility enhance NOAA's core mission to protect life and property, but it will also open up new and exciting areas of research at universities and significant market opportunities for the private sector. NOAA has 6 new strategies in key science and technology focus areas. These are in the fields of artificial intelligence or machine learning, uncrewed systems, cloud computing, data, citizen science, and omics, or the use of advanced methods to analyze materials such as DNA, RNA, or proteins. Unlocking the full utility and potential of NOAA's massive and diverse data is the purpose of the agency's new cloud and data strategies. They are also integral in implementing a collection of strategies to dramatically expand emerging science and technology that will drive innovation and guide transformative advancements in NOAA's science products and services. Finally, things are happening at warp speeds in the world of data. Every day, NOAA's networks of satellites and Earth-based observation systems collect some 20 terabytes of environmental data. This enormous collection of observations allows us to forecast the weather, monitor Earth's climate and oceans, and map natural hazards, helping save lives, protect our infrastructure, and support our blue economy. We are now using AI and machine learning to increase efficiency, precision, and objectivity for many scientific tasks that are dealing with big data within our organization. On the technology side, we have been moving more and more towards open data and shared services for the common benefit of our scientists, GIS analysts, and our partners. Randy showed a great example of how our NOAA Geo platform implementation of ArcGIS Online provides authoritative data through Esri's Living Atlas. NOAA is also starting to explore the benefits of hosting ArcGIS Enterprise in the cloud and Kubernetes. In closing, I want to thank Esri for the opportunity for myself and my other NOAA colleagues to speak with you today. We hope that you have learned a little bit more about NOAA as America's data agency and how we are using GIS to meet our various geospatial mission areas, including protecting and powering the blue economy. Thank you again.